you should already have the last two theorems of the day, Theorem 10.12 and Theorem 10.13, written down. While Theorem 10.12 is long, you have certainly seen more difficult. What Theorem 10.12 is saying is that if you have a triangle where one of the sides is the diameter, then it has to be a right triangle. Let me explain why that's the case. So suppose you have a circle here, and we know that one of the sides of the triangle is the diameter. And so I'm going to draw the diameter into the circle like such. Now, I can finish the circle or finish the triangle any way I want, but what we're going to find out is that it will always be a right triangle. No matter how, let me get rid of the way I drew it, no matter how I draw this triangle, as long as one of the sides is the diameter, it has to be a right triangle. You can see that there's no other way to do this. No matter how I connect it, if one of the sides is the diameter, one of these angles is always 90. Well, why is that? Well, in this particular circle, half is always 180 degrees. So here's 180. And if this particular angle is inscribed and it opens up to 180, then we know that it has to be half of that measure, which will always be 90. And so again, Theorem 10.12 is just saying that if you have a triangle and one of the sides is the diameter, it has to be a 90-degree angle. It has to have a 90-degree angle. There's no way of getting around that. Theorem 10.13 is a little bit more interesting, but not any more difficult. If you have a four-sided figure inscribed in a circle, then the opposite sides are supplementary. The opposite angles, excuse me, are supplementary, which means that this angle right here and the angle that is across from it must add up to 180 degrees. In addition, these two would also have to add up to 180 degrees. This is not something that is true about all quadrilaterals. It is only true if the quadrilateral can fit perfectly inside a circle. So, given these two facts, let's see if we can solve a couple of problems. So my first problem, I want you guys to put this in your notes. Here's my circle, and I'm going to draw the following figure. We're going to have a triangle where one side goes through the center, just like this. They're going to tell us that this angle right here is 2x, and they want us to solve for x. Well, according to Theorem 10.12, because one of the sides of this triangle is the diameter, the angle that is across from it must be 90 degrees. So I know that this angle right here is 90 degrees. So all I need to do now is divide by 2, and we can see that x must be 45 degrees. And there's not too much involved in that particular problem. Suppose we were given a four-sided figure inside one of our circles. So here's our circle, and let's build a four-sided figure here. Let's see, 1, 2... Okay, so here's our figure, and we're going to be given a couple of the measurements. We're going to be told that this angle right here is 120, this one is 80, this one is Z, and this one is Y. And we're told to solve for the missing values here. Let me rewrite my 120. There we go. So according to Theorem 10.13, if we have a four-sided figure inside a circle, then the angles that are opposite of each other must be supplementary, meaning they have to add up to 180 degrees. So if this is 120, the angle that's across from it has to be 60, because 180 minus 120 is 60. So Y is 60 degrees. Z has to be 100, because 180 minus 80 is 100. So Z is 100 degrees. So now these are fairly basic examples. Try a couple of these problems on your own. So on page 558, I want you guys to try numbers 13 through 16. A couple of them have some variables like we see in our first example up here, and some of them are a little bit more cut and dry like in our second example, but give them a shot and then come back together and discuss.